Hello, welcome back. In our today's class, our focus is to convert numbers from other number bases to base 10 numbers. Base 10 numbers are also referred to as the denary or the decimal numbers. So what we want to focus on is to demonstrate how you can convert between a number in a base that is not base 10 to another number that is in base 10. We are going to take a few examples to demonstrate how to do this. So to begin, we are going to use example A as 1101 base 2. Our focus is to convert this number to base 10. If you are given the opportunity, what would you do? Well, to begin, you should take note that there are two different ways of carrying out this operation. One is the successive multiplication method, while the other one is the expansion method. First, I am going to show you how we use the expansion method to work. So to do that, you begin first of all by multiplying each of the digits that make up the number you want to convert by the base. So I'm going to multiply like this. 1 is going to multiply 2. When you do that, add the next one this way. The next digit is 1 multiplying 2 again. That's the second one. Add 0 multiply 2. 0 multiply 2. And add the last digit you have here is 1. So 1 multiply 2. When you do this, that is the first stage. The next thing to do is from the last multiplication that you have just done, start giving the number 2 powers from 0 to the highest. What this means is the last 2 takes the power 0. The next 2 takes power 1. Next takes 2. And the last one takes 3. What this means is that the highest power of 2 will always be 1 less than the total number of digits that you are given to convert. See, here we have 1, 2, 3, 4 digits. But the highest power of 2 is 3 because one of them is 0. Did you get the point? So now we are going to simplify. We have just expanded. Let's simplify our expansion. 2 to the power of 3 will give you 8. So 8 multiply 1 is 8. Write it down. Add 2 to the power of 2 is 4. 4 times 1 is 4. Next, 2 to the power of 1 is 2. 2 times 0 is 0. So if you add 0, and the final one is 2 to the power of 0 is 1. So 1 times 1 is 1. Now all we need to do is to add up our values here, and that will give us our final answer in base 10. Let's do that. 8 add 4 gives you 12. 12 add 0 remains 12. 12 add 1 is 13. So here our final answer is 13 to base 10. That's what you're looking for. The decimal or the denary numbers can actually be written without the number base written right the way I have done. So instead of writing it as 13 to base 10 this way, you can also write it simply as number 13. You will be correct. What it simply means is that 13 is in base 10. Now I promised to show you two methods of doing that, and the other method is called the successive multiplication method. This is the easiest method, but you need to pay very much attention to know exactly how to carry out the operation. So watch me. Looking at what we have here, I'm going to do what we call successive multiplication this way. First, I'm going to go with the first digit, which is 1, and multiply it by the number base. Multiply it by 2. 1 multiplied 2 is going to give me the number 2. Once you get this answer, take the second digit and add it to it. So 2 plus 1 is going to give me the number 3. Now that I've gotten number 3, next is multiply it again by the number base. So 3 times 2 is going to give me 6. Since I've reached this level, now the number 0 will be added to it. Add 0. 6 add 0 is going to give me 6. Now that we are done with 0 and it's the process of addition here, the next to be done is multiply by the number base again. 6 times 2 is going to give you 12. Now the last digit is 1. Since I've already multiplied, all you need to do is to add the last digit, which is 1. So 12 plus 1 will give you 13. Since you finish all the digits, that's your answer. 13 to base 10. Or you can easily write it as 13. Do you see how easy this method is? So like I told you before, The successive multiplication method is the easiest method of changing from other number bases to base 10, but you need to be extremely careful. The trap here is that someone can easily do an addition when he or she is supposed to do a multiplication. So you should know that the process is multiply, add, multiply, add, multiply, add, and it continues till you are done. All right, that is clear. Let's take another example. Let's go to a number with a base that is beyond 2. So let's take the number 7, 5, 6 in base 8. Actually, base 8 is referred to as the octal. Yes, just like you have it in your polygon. Remember that? You remember your octagon, yeah? All right, so we're going to convert 756 base 8 to a number in base 10. You can either use the successive multiplication method, which I showed below, or you can use the expansion method. So let's do it this way. We'll begin by saying 7 multiply 8. Since I have 3 digits, it means the highest power of 8 will be 2. Add 5 multiplied by 8, power 1, and add 6 multiplied by 8 to power 0. Now we're going to simplify. First, we know that 8 squared is going to give us the number 64. So all we need to do at this stage is to multiply the number 64 by the number 7. So if we multiply the number 64 by the number 7, that gives us 448. That's for this part. Add, this is 8 to power 1, which is 8. So 8 times 5 gives you 40. And the next one, 8 to power 0 is 1. 1 times 6 is 6. All you need to do at this stage is add up all your numbers. So if I add 448 to 40, and I also add 6 to it, that leaves me with the answer 494. You can write base 10 this way, or you simply write it as 494. Whichever way it is expressed is correct. Now you can try out the successive multiplication method to see if it works for you. Make sure you apply it exactly as it should be. Now to prove to you that a number which is already given in base 10 will remain the same when expressed again in base 10, let's take an example that's already expressed in base 10 and try converting it to the same base 10. Let's see how that works. So let's take the number 135,206,94. This is actually lengthy. This is expressed in base A. Remember that when you get to 9, the next from 10 is expressed in letters A, B, C, D, E, F, etc. Okay, so when you have base A, simply means base 10. We want to convert this same number to base 10 again. How is that going to be? Okay, this is going to be very lengthy, but let's do it. So we go like this. First of all, multiply 10. First, count how many digits you have. 1, 2, 3, 4, 5, 6, 7, 8. So the highest power you're going to have here is 7. All right. Add 3 multiply 10 to the power of 6. Add 5 multiply 10 to the power of 5. Add 2 multiply 10 to the power of 4. Add 0 multiply 10 to the power of 3. Add 6 multiply 10 to the power of 2. Add 9 multiply 10 to the power of 1. And finally, add 4 multiply 10 to the power of 0. You can use the successive multiplication to do that as against what I am doing, which is currently the expansion method. Okay, when 1 multiplies any number, that number remains 1. So all I need to do now is to look for 10 to the power of 7, and that's going to give me 10 million. So I'll write it down right here. 10 million. Add 10 to the power of 6 is going to give me 1 million. So 3 multiply 1 million gives me 3 million. 3 million. All right. 10 to the power of 5 is going to give me 100,000. So 100,000 multiplied by 5 is going to give me 500,000. Next, 10 to the power of 4 gives you 10,000. So 10,000 multiplied by 2 gives you 20,000. And here 0 multiplied 10 to the power of 3 is 0, so that is skipped. Here 10 squared is 100. 100 times 6 is 600. Next, 9 times 10 gives us 90. This is 10 raised to the power 0, which is the same thing as 1. So 1 times 4 is 4. Now let's try adding all these together and see what that is going to result in. So first, 10 million, I am going to add 3 million to it. Okay, then I am also going to add 500,000 to it. Next, we add 20,000. Next, we add 600. And next, we add 94 to it. That is going to give us a total of 13520694 to base 10. Or you can write it without the base 10. Just write it as 13520694. Now compare the answer we have right here with the question and see that both of them are exactly the same. 135,135,206,206,94. Did you see it? So I told you before solving this problem that when you convert a number that is already in base 10 back to base 10, the number is going to give you exactly the same thing. It's going to get back to what it was before you started. This is how you express numbers that are given in bases that are not base 10 to another number in base 10. You can take some examples for yourself and see if you have understood this method. Meanwhile, using the successive multiplication method helps a lot. So you can try working it out to see if you have understood how to operate this. I believe this helps a lot. Thanks for watching.